Okay, we're in section 66 now. And again, without sounding like a broken record, there's contents to get through, examples to get through, and a majority of work is going to be spent on exercises. It's a lot of work, though. And it was a lot of work for me, too. It really was. My name is Ron Bannon. You're looking at a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. Right, this PDF document is being made available to the Prison Mathematics Project participants only. I realize that some people may want access to this document, and if you do, you should reach out to me by email, and I'll let you know when it's going to be published. Right, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, so, I'm looking through the document, and, certainly we want you to read it. Certainly, I read through the document. What I mean by that, I read through Wells's work. He's really quite good at it, but everything to him is sort of like recognizing things and then doing these things when you recognize those things. And it's great to have that recognition skill. A lot of times, though, what happens to students is they get thrown in exams and they don't recognize the problem. And that's what I'm saying. You really should have some options. So I'll be honest with you. If I were looking at the question, what I would do is I would say, gee, I don't know even where to start, but I'm looking at and saying it looks somewhat recognizable to me. The first thing I would probably do is I try to factor, because there's not much else I could do about it. Like, for example, the top equation, what would you get? You would get x, let's see, x, this is a perfect Q problem, x minus y, and then you get x squared, let's see, plus xy, plus y squared is equal to 9. Now, that may not help you, but what I notice immediately over here is I know what x minus y is. It's 3. I'll write that down for you. But again, this could be a dead end that leads nowhere. But at least I'm walking, all right? Now, when I say I'm walking, I could be walking down a dead end, but I'm walking towards there. So I want to keep going, and as I do that, I'm going to just divide both sides by 3 now. And I get something that, is not that helpful, but it wasn't difficult to get. But I still have an equation with 2 unknowns in it. So the next thing I would try to do is I try to reuse this thing again. And I'm going to solve this thing for y. What do you get? X minus 3 equals y. Let me see if I did that right. Yeah, I think so. So I'm going to plug that in. What do you get? You get x squared plus x. What's y? Y is going to be x minus 3. We'll figure this out later. Plus y squared. Well, that's x minus 3 squared is equal to 3. Let's go through the work. You get x squared plus x squared minus 3x. That wasn't so bad. Then when you go over here, you get x squared minus 6x plus 9 equals 3. It's not bad work, by the way. Let's see, 3x squared minus 9x, and I'll take 3 from both sides, plus 6. Well, I'm going to divide by 3, and what do you get? X squared minus 3x plus 2 equals 0. I'm going to make some attempt to factor it. And what do you get of your x and x? 2 and 1, minus minus, x equals 1, x equals 2. Wow, that turned out to be pretty nice. Here's my problem, though. I need to know what y is. So what's y going to be? If x equals 1, and again, I'm looking at this, what would y equal to? That would be 1 minus 3, which is minus 2. If x equals 2, what do you get? Y would equal minus 1. All right? So what I want to do is I'm going to say, I think these are solutions to the problems over here. So someone says, what do you mean you think? I don't know. I have to check it. So one of the solutions is 1 comma minus 2. The other solution is going to be 2 comma minus 1. I'm going to check them. And someone says, where do you check them? You're always going to check them in the original system. All right? What's the original system? This is the original system here. Let's check one at a time. I'm going to check this one first. What would you get? 1 cubed is 1. And let's see, minus 2 cubed is minus 8. Minus 8 is plus 8. That does equal 9 as advertised. What's the next one going to be? 1 minus a minus 2, which is 1 plus 2. That does equal 3 as advertised. Let's check this one out. And what do you get over there? 2 cubed is 8. Minus 1 cubed is minus 1. So it's going to be plus 1, because minus minus 1 is plus 1, equals 9 as advertised. What do you get for the second equation? 2 minus a minus 1, which is 2 plus 1, and that equals 3 as advertised. So this looks good. Now, certainly what I want to get across to you is that, Wells in his work does make errors. Right? I can't remember how many errors I counted, but it's not many. He was really quite good at it. They must have had a team of people working on this. But I want to look at the picture. And the picture is going to be x cubed minus y cubed is equal to 9. We'll talk about that in a moment. That's the first line. And the second one is x minus y equals 3. What's the easy equation to graph first? Well, I'm going to say this one here is easy. It's just a line. And what does the line look like? Well, if you looked at it, it would be, you put down x and y. X is 0. What would y be? Oh, minus 3. That was easy. Let's say y is 0. What would x be? 3. So I get a point there. That's 3, 0. And minus 3 zeros over there. I'm sorry, 0 minus 3 is over there. So what do? Draw the line in. That was pretty easy. The machine did that picture, by the way. And then someone says, I wonder what this thing is over here. Well, I mean, you could do it, but the bottom line is it doesn't have any nice numbers to it. But if you put some numbers down here, like, for example, you did a table, which is probably the worst thing you could do. If you chose x to be 0, y would be the cube root of, the minus cube root of 9, which is like minus 2 point something. I'm seeing that. And then if I did, y is 0, you would get the cube root of 9 here. It's not so bad. And what do you get with that? Would be a little bit bigger than 2. Now, by the way, that's about the extent of it, but I hope you can trust that this is the picture they're talking about over here. And that's that cubic problem there. All right, it's a tough graph, though. I'm not saying it's easy. So what are the points of intersection? Well, I'll be honest with you, looking at it, and again, looking at it doesn't mean I'm right. Looking at it, this one looks like 2 for the x, minus 1 for the y. And looking at that point of intersection, it looks like 1 for the x and minus 2 for the y. Are they the answers we got? Let's put this down. The answers we got were 1 minus 2. Yep, I got that one. The other one's 2 minus 1. Yeah, I got it. All right. Now, again, the number 2, I'm going to say that I wouldn't know where to start. But when I say that, I would say, oh, it's this case, that case, the other case. I would just simply play around with it. And me playing around with it doesn't mean it's going to work. But at least you're moving. So I'm going to factor both sides. Difference of squares, right? That's easy. The nice thing about moving is if it's easy to move, you should. And what do you have here? 3x plus 2. That's a sum of perfect cubes, right? Then you get 9x squared plus 6x. Oh, no, minus 6x. I'm sorry. Plus 4. And the second equation is x minus y. I'll put that in factor symbols too. And 3x plus 2. Now, immediately what am I noticing? I'm noticing something that's remarkable. I'm seeing this factor here. So I'm going to divide these things. I'll write that down for you. I'm going to write down, it may lead nowhere, by the way, or it may lead to really tough things too. You know what? I'm jamming things. I don't like jamming it in. I'm going to erase that and try again. Actually, I'm doing chicken scratch. I really don't care if I'm jamming things in. I'm just trying to get to the end of the problem. I'm going to divide the left side by x minus y. Now, by the way, this and this are identical, but there is a problem over here. And I want to point out what the problem is. If x equals y, I'd have a division by 0. And this is a problem for me. That can't happen. That happens, I'm divided by 0, and that's bad news. The other thing is when x is equal to minus 2/3. That's also bad news for me. All right, I'll tell you why I'm dividing by that. But here's the deal. You know what? Let's just check it out. Now, I don't think I have to worry about x equals y, because I'm noticing that it is not a solution to the problem. So I'm going to cross this off. That's not a worry for me, because I'm looking at it. X equals y. What would I get if x equals y over here? Let me write that down for you. You get x minus x equals 3x plus 2. And that would be 0, 3x plus 2. All right? Now, by the way, there is a solution that's minus 2/3. But I'm saying if x equals y, I'm not getting the 0 on both sides, right? Let me just erase that. And don't be alarmed. I'm just thinking. Now, if x equals y in the top equation, when you get x, whoops, sorry about that. you would get x squared minus, I'm sorry, I misspoke there. Let me get my eraser out. If x equals y, you get x squared minus x squared, which is 0 again, 27x cubed plus 8. And what do you get over there? Well, the right side is 0, and the right side is 27x cubed plus 8. And, you know, I'm going to say, well, oh, minus 2/3. That would work again. Let me see if that's true. Yeah, that would give me the 0. So this looks like it might be a solution to the problem. Let me just make sure of that, all right? So let me erase. And I'm sort of like thinking about it. And if I erase that, I'm going to say, it looks like, oh, x equals minus 2/3 is a solution to the problem. Let me write that down for you. And that's going to work beautifully. All right? So this is one case I found that's going to work really nicely just by looking for those divisors. So I'm going to erase that now, and I think I found a solution pretty quick to it. All right, so I'll erase this over here. Whoops, sorry about that. I'm going to erase this business over here. I'm done with it. And I'm going to say x equals y equals minus 2/3. If you want, you can check that. I want to go through the check with you. So I'm going to say an answer to this problem is over here is minus 2/3, comma, minus 2/3. All right? Now, so listen, how did you find that so quickly? It was unexpected. I was looking at this and saying if it's a 0 divisor, that would be a problem. And over here I said, well, if x equals y, that's a problem. But now I've taken care of the problem. Let me verify it's true. What are you going to get? You can get 4/9. I'm taking it here. I'll erase this later. Minus 4/9 equals, well, what would you get over there? You would get 27 times minus 2/3, which is minus 8/27. And that would give you minus 8 plus 8. And that does equal 0. All right, that worked out beautifully. Second equation, what do you get? Minus 2/3 plus 2/3 equals 3 times minus 2/3 is going to be minus 2, and minus 2 plus 2 is 0. And that works out beautifully as well. So I found one solution to the problem. It might be a miracle, but we found it. Let me get my eraser out. But there may be others. And that's a problem. And I mean, it's a problem. Like me stumbling upon that by doing a simple division and talking about what I couldn't be doing, dividing it, well, you know, it's a problem. But now I know that, you know, this guy over here, that's a good answer. I've checked it. But now I got another problem on my end. And I'll write this down for you. I'm going to divide, all right? And what am I saying? This answer is no longer, I know that. I don't have to worry about it anymore. What are you left off with? X plus y is equal to 9x squared minus 6x plus 4. And this may lead me to other answers. I don't know. As I do it, though, I want to claim, I'm going to start to erase something here. I'll erase this, so we're done with that. Let me erase this. We've already checked it. We know it's right. And I'm going to erase this business here. Don't be alarmed. And I got to use the second equation to eliminate an x or a y in the problem. So let me see if I can do that. And I'm going to write this down as, let's see what I can do. Minus y, I'll be very careful, equals 2x plus 2, or y would equal minus 2x minus 2. All right, let me get my eraser out. Erase this business here. And I'm going to take this thing and plug it in now. So what do I get? I get x. What's y? It's minus 2x minus 2 equals 9x squared minus 6x plus 4. And now I got an equation I want to know. It's quadratic. I got to figure it out, though. So this is going to be minus x minus 2 equals 9x squared minus 6x plus 4. Let's keep going. This is going to be 9x squared. I want a 0. I'm going to add x to both sides, so minus 5x plus 6. I'm going to say that you're really not going to factor using integers. And I got to find a solution to that problem, by the way. And so I'm going to write this down, quadratic formula. And let's take a look at that. Opposite of b, that's 5, plus or minus Let's see, what's the b squared? 25, right? Minus, let's write this on the side, 4 times 9 times 6. Well, that's going to be 36 times 6, which is 180, plus 36, which is 216. Right? So I'll write that down. Wow, it's complex. What goes on bottom? 18. Now, by the way, some people say I want to stop now because it's complex. I don't want to stop. I want to keep going. I want to make sense out of this problem. And we have a visual, too. We'll get there later. Plus or minus the root of, let me get my eraser out, my chicken scratch on the side. I don't need it anymore. I'm done with it. Unless I made a mistake. But then if I made a mistake, I'm not going to look at my chicken scratch again. So let's see, 175 and 16. That's going to be 191 over 18. And x equals 5 plus or minus I root 191 over 18. I know this seems like a tremendous amount of work, and I want to point out that you really want to find work that you enjoy doing. Now, granted, I can't say this is the most enjoyable thing in the world, but I did find x. Now, someone says, how could you find y? Well, there's two different x's. I'll write them down for you. Whoops. One of the x's is x equals, well, let's write this down, 5/18 plus I root 191 over 18. The other x is x equals 5/18, I'm not beyond making error, minus I root 191 over 18. Now, I'm hoping you remember that we use this over here. All right? So, could I get the y? I think so. And what's it going to be? I'll write this down for you. It's going to be minus twice that number, which is going to be minus 5/9 minus I root 191. Let's be careful now. I'm multiplying by minus 2, right? So it's going to be 9, and then I'm going to subtract 2 away. We'll do that later. Let me do the next one. Y is going to be minus twice that, which is minus 5/9 plus I root 191 over 9 minus 2. I want to clean it up. And so this is so much work, I don't want to clean anything up. I just want to leave it as it is. But I really have to clean it up. All right, so I'm going to write the points down I got now. We have this one here. That's one real solution. I'm going to write the complex ones down now. So 5, let's see, plus I root 191 over 18. And I want to put this number down now. And I got to do that. So I'm going to say, what is that? It's minus 5/9 minus 2. Well, that's going to be minus 18 and 5, minus 23, right? Let's see, and that's going to be what? I got to be real careful here. Oh, minus I root 191 over 9. All right, I'm going to commit that to my second answer. Let's put the next one down. And that's going to be 5 minus I root 191 over 18, comma. I got to do this business over here, by the way. That doesn't look too bad. I kind of just did it before, right? So 9. And let's see if I get there. And what do you get there? Minus 5, minus 23 again. Plus I root 191. All right, I'm going to commit to that one over here. Let's get my little red thing out. Make sure we got all these answers. Remember, we got this one before. Let's see if I got these two. Now, what am I seeing over here? Let me see if I got this one over here. Yep, I'm seeing it. Did I get this one? Yep, I'm good. Now, here's your problem. There's only going to be one point that you're going to witness in a real plane. What's that point going to be? Well, I have to graph out both of those. And, you know, I always say, thank God for computers. I graph the system, and I get one point of intersection over here. And someone says, what is that point? I don't think I could read it from the graph, by the way. But I do know, looking at it, and you could blow this thing up, I know it's a proper fraction in both directions, and they're certainly negative. Do I know what those numbers are? Of course I do. it's this number over here, which is minus 2/3. I'll write this down for you now. But there is no way I could have read that from the graph. I don't care how good the graph is, I couldn't have gotten those numbers from the graph. I might have been able to ballpark it and say, yeah, it looks roughly 2/3, to the left and roughly 2/3 down, but I couldn't commit to that. I had to do it by algebra to get those points. All right? So someone says, oh, you wasted time getting the complex things because I can't see those. No. Whether I can see them or not, they're there. All right? They're there. All right, let's keep going. And I want to go to the next thing up, which I'm hoping is not another example because these things are tough. All right. Oh, exercises. What does that mean? Here's where the work is. And what's the work going to be? The work is going to be doing this stuff over here, the exercises. It's where the majority of problems are. All right, what do you mean by that? It's going to be work. And certainly someone says, do you find this easy? No. I got to do work. I hit a dead end. I back out. I try again. I try again. I try again. Try. I mean it. Try. Try what I was doing. Try different paths. You know what? You might say the path you're taking is different than the path I'm taking. What do? We give you answers and we give you graphs. That's nice to have. That's something that Wells was not providing. All right? I do it for all the problems that he's giving. I put down the answers and I put a graph down for you. For all the problems, right? For all the problems, the points of intersection and the graph, for all the problems. It's going to take time and effort, though. It's not something that happens quickly. Solutions and a graph. Whoops, sorry about that. And they get more difficult. There's no doubt about it. They get difficult. Solutions and a graph. Ooh, this one looks tough. Solutions and a graph. Solutions and a graph. Every single time. Wow, there's a lot of questions. 8, 9. Will it ever end? 10, 11, 12, 13. Again, you decide how much time and effort you're going to put into it. I'm going to say the more effort you put in, the better it's going to be for you. 14, 15, whoops, that was 16. There's a lot of problems. Wow, 16. Then what do you get to? The Sage Business Computer Algebra System, or a CAS. It's open source software. Go to this website, download it, or interactive web-based application. You can type some of that code in if you like. Here's the deal, though. I'm not interested in the code. What am I interested in? Your ability to do the problems as well as specified. Here's the deal, though. If you find an error, which you're most likely going to find an error in my work, please reach out to me. What's my name? Bannon. What's my email address? B as in boy, the @ symbol, NNON.US. All right? Bannon. Thank you so much for paying attention.